For centuries, Stromboli's volcanic island seemed almost predictable, its eruptions a familiar backdrop north of Sicily. But in a recent 7-day stretch, more than 1,800 violent blasts shattered all scientific expectations, putting the Mediterranean lighthouse of the sea on maximum alert. Today, scientists warn that calamitous forces are quietly building beneath a landmass rivaling Manhattan in size. What's fueling this dramatic surge, and could the worst be still to come? Stromboli rises from the Tyrrhenian Sea like a dark, solitary beacon, 12.5 kilometers from end to end, its volcanic slopes forming a nearly perfect cone. The island sits about 93 kilometers north of Sicily, separated from the mainland by open water and the scattered silhouettes of the Aeolian archipelago. Its summit towers 924 meters above sea level, making it one of the tallest volcanoes in Europe when measured from the seafloor. The landmass itself rivals the size of Manhattan, yet feels infinitely more remote. No bridges, no highways, just a single port and a handful of narrow, winding paths that cling to the slopes. Stromboli's isolation is more than just a matter of distance. The island's steep cliffs plunge straight into the sea, leaving little flat ground for homes or crops. The main village, San Vincenzo, hugs the eastern coast, sheltered from the worst of the prevailing winds. To the northwest, the Sciara del Fuoco, a vast black scar, funnels lava and debris directly into the water, a reminder that the volcano's power is never far from the surface. Living here means accepting the possibility of sudden change. The entire population, about 400 residents, shares this confined space with a force of nature that has shaped every contour of the island. Each street, every vineyard and olive grove exists within sight of the crater's rim. From the highest terraces, the view stretches across open sea to the distant haze of Sicily. On clear days, the volcano's plume is visible from the Calabrian coast, a thin column rising from the horizon. The scale of Stromboli becomes most apparent when measured against the world's great cities. Manhattan may be crowded with skyscrapers, but Stromboli's summit stands higher than any building in New York. Its footprint, though similar in size, is defined by rugged slopes and deep ravines rather than city blocks. There are no escape routes by land, only the sea offers a way out. This physical reality shapes every emergency plan, every calculation of risk. When the volcano stirs, the sense of exposure is absolute. The island's beauty and its danger are inseparable, bound together by geography and the ever-present possibility of eruption. Stromboli's restless nature is written into the very rocks beneath its slopes. For nearly 300,000 years, this island has been shaped by the collision of tectonic plates deep beneath the Mediterranean. The African plate pushes northward, sliding under the Eurasian plate in a process called subduction. This slow-motion convergence melts rock far below the surface, creating vast reservoirs of magma that feed the volcanoes of the Aeolian arc, including Stromboli, Etna, and Vesuvius. The Aeolian arc traces a sweeping curve across the Tyrrhenian Sea, a chain of islands born from repeated eruptions and ancient cataclysms. Stromboli stands near the northern tip, its activity fueled by a continuous supply of magma forced upward by the grinding plates. Unlike many volcanoes that sleep for centuries, Stromboli is famous for its near-constant eruptions. Scientists call this Strombolian activity, short, frequent bursts that have earned the volcano its nickname, the lighthouse of the Mediterranean. These eruptions are not accidents of fate, but the direct result of the island's place on one of Earth's most active geologic frontiers. This cycle of eruption and renewal has left dramatic scars on the landscape. The Sciara del Fuoco, a broad, blackened chute on the volcano's northwest flank, is the product of repeated collapses over the past 5,000 years. Each time a section of the volcano's side gave way, millions of tons of rock and ash tumbled into the sea, reshaping the coastline and opening a direct path for lava flows. The Sierra del Fuoco acts as a natural safety valve, channeling most eruptions safely away from inhabited areas. But it also stands as a reminder of the volcano's power to transform itself in a single catastrophic event. The forces at work here are slow but relentless. Magma rises, pressure builds, and the ground itself can shift or collapse with little warning. These processes explain why Stromboli's eruptions are not rare outbursts, but a fundamental part of its existence. Every explosion, every glowing fountain of lava, is a visible sign of the ongoing battle between the deep earth and the surface above. This is why scientists expect activity here, not as an exception, but as the rule. The island's past is a record of constant change, shaped by the same tectonic forces that continue to drive its eruptions today. In early 2025, Stromboli's summit entered a phase of relentless explosive activity. Official records from the Italian National Institute of Geophysics and Volcanology show average explosion rates climbing to between 8 and 13 events per hour at the North Crater, with additional activity at the south-central vents. Over the course of 1 week, this meant as many as 1,500 distinct eruptions, each one cataloged by a network of seismic sensors and thermal cameras that never sleep. The numbers, while not outside the upper range of Stromboli's historic behavior, represent one of the most active stretches in recent years. Each explosion sent incandescent lapilli and volcanic bombs arcing above the crater rim, sometimes more than 150 meters into the air, lighting up the night sky and scattering ash across the slopes. Seismic instruments picked up a parallel surge in volcanic tremors and rock fracturing events. These signals, sharp, impulsive bursts, hint at magma forcing its way upward, cracking brittle rock as it rises. While the daily earthquake count rarely exceeded 20, the energy released was significant enough to keep the island's monitoring network on high alert. Scientists noted that this level of sustained activity, while not labeled as unprecedented in official bulletins, demanded constant vigilance. The alert status remained at yellow, but the tone of daily reports grew more cautious as the week wore on. For the people of Stromboli, these numbers are more than abstract data points. Each explosion rattles windows in San Vincenzo, each tremor a reminder that the volcano's rhythms can change with little warning. The catalog of events from February stands as a stark record: hundreds of eruptions, dozens of seismic bursts, and a volcano that refuses to settle. The raw data leaves little doubt. Stromboli is restless, and its story is still unfolding. On Stromboli, the line between routine and emergency is drawn by a dense web of scientific instruments. High on the slopes and tucked into the crater's rim, seismographs and thermal cameras operate day and night, feeding a constant stream of data to the Italian National Institute of Geophysics and Volcanology, INGV. This network does not just record explosions, it captures every tremor, every subtle shift in temperature, every pulse of volcanic gas. The island's isolation makes these tools essential, turning raw numbers into the first hints of danger long before ash darkens the sky. At the heart of this operation are the scientists tasked with interpreting the signals. Dr. Eugenio Privitera, director of INGV's Osservatorio Etneo, describes the recent activity as one of the most sustained bursts in years. Hourly frequencies have climbed as high as 13 events, with explosions from the North Crater sending incandescent debris more than 100 meters above the rim. The monitoring team, led by senior volcanologists like Dr. Marco Neri, tracks these patterns in real time, looking for the telltale signs that might separate a standard eruption from something far more dangerous. The instruments themselves are a testament to decades of investment and adaptation. Seismic stations dot the volcano's flanks, sensitive enough to register the tiniest rock fracture. Thermal cameras capture the glow of fresh lava even through thick clouds or darkness, while gas sensors measure the invisible plumes streaming from the vents. Each device is part of a larger system, cross-checking and validating every reading to avoid false alarms. When an explosion occurs, its seismic signature is matched against visual and acoustic data, ensuring that every event is counted and cataloged accurately. This vigilance comes with its own challenges. Equipment must withstand corrosive gases, constant ashfall, and the risk of being buried by new eruptions. Maintenance teams work in hazardous conditions to keep the network operational, knowing that any gap in coverage could mean missing the early warning for a major event. Despite these obstacles, the monitoring array has given scientists an unprecedented window into Stromboli's behavior, allowing them to recognize patterns and issue timely alerts. In a place where every minute counts, trust in the data and the people who interpret it can make all the difference. Pressure beneath Stromboli is not just a matter of what is visible at the summit. Deep underground, the volcano's body acts like a vast, hidden reservoir, slowly filling with magma rising from the Earth's mantle. As new magma accumulates, it pushes against the overlying rock, stretching and flexing the crust in subtle but measurable ways. Scientists track these movements using a network of GPS sensors and tilt meters anchored around the crater and along the Sciara del Fuoco. Each instrument is sensitive enough to detect even the smallest changes, millimeters of movement that signal shifts in the volcano's internal plumbing. The process is known as magmatic inflation. Imagine inflating a balloon beneath a heavy blanket. As the balloon expands, the blanket rises and stretches, straining against the pressure below. In volcanic terms, the blanket is the ground itself, and the balloon is a pocket of gas-rich magma. When the pressure builds faster than it can be vented through small, regular eruptions, the surface begins to lift. At Stromboli, typical annual swelling is just 0.8 to 1.6 inches, barely enough to notice without precise instruments. But recent monitoring reports suggest that, at times, localized uplift near the North Crater can reach several centimeters in a matter of days. While some media have cited dramatic numbers up to 10 centimeters or nearly 4 inches, official bulletins from Italy's National Institute of Geophysics and Volcanology have not confirmed such large, sustained deformation during the current unrest. Instead, scientists are watching for short-lived pulses of inflation that often precede the most violent explosions. The danger lies in what this inflation represents: fresh magma under mounting pressure, gas trapped and seeking a way out. As the crust stretches, cracks can form, and the smallest breach may trigger a sudden release. The more quickly the ground swells, the greater the risk that the volcano's next move will be abrupt and forceful. Instruments record these changes in real time, turning the invisible build-up into hard data. Each uptick in surface elevation, each subtle tilt, is a warning that the system is primed, much like a balloon that has nearly reached its breaking point. For scientists, these measurements are not just numbers. They are the earliest signs that a major event could be imminent. And the key to understanding how quickly a routine eruption can escalate into something far more dangerous. July 2024 delivered a stark reminder of what Stromboli is capable of. That month, the volcano unleashed over 3,000 explosions in a single day, an eruption rate that dwarfed even its most active weeks. The sequence began with hours of mounting tremor, each burst of seismic energy recorded by the island's monitoring network. As pressure built, vents at the summit erupted in rapid succession, shooting incandescent rock and ash high above the crater. Locals described the sound as a constant roar, punctuated by the sharp crack of larger blasts. By midday, the eruption's intensity reached a level not seen in years. Columns of ash rose hundreds of meters, drifting over the island and blotting out the sun. On the northwest flank, the Sciara del Fuoco channeled fresh lava and debris directly into the sea. The sudden rush of material displaced enough water to generate a 40-centimeter wave, a small tsunami that raced across the shoreline. While the wave caused no serious damage, it served as a warning that volcanic activity here can threaten not just the land, but the sea as well. In the aftermath, scientists cataloged the event as a paracismal eruption, a rare, high-energy episode that stands apart from Stromboli's usual rhythm. The data from July 2024 now serve as a reference point, a benchmark for what can happen when the volcano's internal pressure is allowed to build unchecked. For the residents and the monitoring teams, the lesson was clear. Similar warning signs cannot be ignored. 400 people call Stromboli home, their lives woven tightly with the rhythms of the volcano. The evacuation plan posted in the mayor's office promises that everyone can be off the island in under 2 hours. A bold claim tested only in drills, never in the chaos of a real eruption. Each household knows the sound of the emergency siren, the coded messages sent to mobile phones, and the route down to the port. Yet for many, these protocols feel abstract compared to the daily reality of tending vineyards, mending fishing nets, or watching the volcano's plume drift across the sky. Mayor Luigi Russo, who has led the island for over a decade, faces a dilemma familiar to every leader of a small, exposed community. He says the plan is ready, but it has never been tested under true emergency conditions. The last full-scale drill, in July 2024, revealed gaps that paper plans could not predict. 2 families missed the muster point, a radio failed, and loading the boats took nearly the entire 2-hour window. The Coast Guard stood by, engines running, as volunteers checked doorways for stragglers. Some, like Antonio, a fisherman whose family has lived here for generations, refuse to leave even when the order comes. He says his father and grandfather watched the volcano, and we know its moods. For Antonio and others, the island is not just a place to live, but an identity that cannot be abandoned at the sound of a siren. This deep connection complicates every effort to prepare for disaster, turning a technical challenge into a human one. When the volcano stirs, the question is not just how fast the boats can leave, but whether everyone will choose to board them. Across Stromboli, scientists are watching for the next move. The current crisis is not confined to a single day or week. It stretches into an open window with the possibility of a major eruption lingering from now through December 2025. Every new tremor, every spike in explosion frequency is logged and analyzed in real time by teams at the Italian National Institute of Geophysics and Volcanology. Their network of instruments, from high-sensitivity seismographs to thermal cameras, provides a level of surveillance never before achieved on this volcano. For the first time, researchers are able to detect and track geophysical precursors as they unfold, capturing the earliest signs of escalation before an eruption strikes. This is more than a local story. The data streaming from Stromboli is being used to refine global models of volcanic risk. Patterns observed here, like the relationship between deep seismicity, surface inflation, and explosion rates, are informing forecasts for other volcanoes in Italy and around the world. Scientists know that the stakes are high. A paroxysmal eruption could arrive with little warning, and the lessons learned now may save lives elsewhere. Each hour that passes without a major event is both a relief and a reminder that the system remains primed. The world is watching, and the next chapter could begin at any moment. Stromboli's restless power is not a distant threat. It is a living force shaping lives and coastlines right now. As real-time monitoring sharpens, the line between warning and disaster narrows. For islanders and scientists alike, vigilance is survival. The Mediterranean's future will not be decided by history. It is written in every tremor beneath our feet.